All right, so we are going to do these things called special functions. It's basically a lot of graphing today, okay? We're going to do a lot of graphing. So you need to pay attention because some of these graphs you've never seen before. Okay, here's my guess. Chan, are you going to listen now? All right. So the first thing we're going to do is this little title, I guess, for this type of graphing or this type of function could mean a lot of different things. But they call it a piecewise function, piece. So it's like a piece of a graph. It's not a whole entire line like we're used to graphing. It's called a piecewise function. And there's several different things that could be considered piecewise functions. I'm going to give you one that's kind of, I don't know if it's basic or not, but I'll show you one. Remember, we use f of x a lot, don't we? Instead of using what? Instead of using y. Instead of using y equals, a lot of times we use f of x. Every once in a while they'll throw y in there, but a lot of times from here on out you're going to see f of x equals. Okay, so just kind of get used to it. It's not that big of a deal. It just means y equals something. Now watch, I'm going to give you actually 3 different graphs all in one. All right, so I'm going to go that, I'm going to go that, and then I'm going to go this. So what does this mean? It means y equals x plus 3. Then I'm going to graph y equals x squared. Have you done an x squared graph before?
No.
Maybe, maybe not. I'll show you. It's pretty easy. And then y equals 1. All right. But what we're going to do is we're going to put restrictions. Normally we would just go, watch, I'll just do this. I'll just do this real quick. Here's what we would normally do for y equals x plus 3. How would you graph y equals x plus 3? Well, the y-intercept is 3, correct? And what's the slope? It's 1. So it's 1 over 1. So go up 1, go over 1, right there, go down 1, go right, and then boom, there's your graph right there. Agreed? And you put arrows on the end and all that kind of stuff. But what you're going to do, they're going to restrict the domain. Remember talking about domain and range? Okay, the domain is the x variables, okay? It's all the x coordinates, I guess. It's probably a better way to say it. It's all the x values. That's what I was looking for. So we're going to restrict it. So right now, look at the domain. It's unrestricted, right? The x could go all the way to here because I could go all the way to here to x. Will I eventually get to the graph? Yeah, if I go down and I hit the graph down here, right? I could go all the way out here. Could I eventually get on that graph? Yeah, if I go up here far enough. Would you agree? Okay, so we're not restricted on a line like this, but we are going to throw some restrictions in. Let's just do x equals or y equals x squared, just to kind of give you an idea if you haven't done that before. So y equals x squared. Here's a nice way to do this. Remember when you did Algebra 1, you first started doing graphs with a little table like this, a little chart? And let's put a couple numbers in. Let's go -2, -1, 0, 1, 2. Remember doing that when you first did Algebra 1? You figured out how to graph a straight line? Yes? Okay. And then you just put a few points on there and you're like, oh, okay, it's starting to look like something. Then you just connect them and you're good to go. We're going to do the same thing here, but it's going to look a little different. We're not really here to teach you how to graph this. I think they kind of make the assumption that you already know how to do it. And in Algebra 1, a lot of classes, they do teach you how to graph this, but I'm going to work on the assumption that you don't. So let's put some points in here, -2. So I put it in for this and I square it. What do I get when I square -2? It's +4, correct? Because it's -2 times -2, which is +4. Let's put a -1 in for this. What's that going to give you? It's going to give you a 1, correct? Put a 0. 0 squared is 1. Put a 1 in there. 1 squared is 1. Put a 2 in there. 2 squared is 4. No, I was just checking to see if you were paying attention. 0 squared is 0. All right. I was just joking. I messed up. So, yeah, 0 squared is 0. I probably was thinking of the next one. I was just getting ahead of myself. So let's plot this. 0, 0 is right here. 1, 1 is right there. -1, 1 is right there. 2, 4 is up here somewhere. And then -2, 4 is up here. I could keep going. But what is it? Is it just a straight line? Is it like a straight line here? No, it's not even a straight line between these three, right? This actually curves up. It curves like this, and it curves like If I get in there, yep, just barely hit it. That right there, it's called a parabola. We'll learn about that later on. We're going to get into a lot of detail, believe me, on these things later on. But right now, it's not that hard to graph. Would you agree? Now, right now, let's take a look at the domain of this thing. The domain is unrestricted because I could keep on going on the x. I'd eventually, if I go up high enough, I'd hit that graph. Yes? Is there anywhere on the x-axis that I can't go? Nope, I can go anywhere on the x-axis because eventually, if I go up high enough, I'd hit that graph. Yes? So the domain is unrestricted. Okay, what about this? Y equals 1. What does that mean? It means it hits the y-axis at 1 and it's just a what kind of line? Horizontal line, and it keeps on going. That's zero slope, right? It's a horizontal line. That's what that means right there. Okay, but again, is the domain restricted on this? No. If I don't have anything, it's not restricted. That means the x could go as far left as it wants. It could go as far right to it as it wants. Everybody with me on that? All right. But now what we're going to do, I keep saying the restricted thing. What do you think we're going to do to the domain of these three? We are going to restrict it, okay? And let's show how they restrict it. So they say this. They say graph, okay? It says to graph y equals x plus 3 if, all right? This is where this restriction comes in. If x can only be less than -2. That's our restriction. Okay, so we're only going to graph the part of the graph, okay, not the whole thing, just a part of it, a what of it? A piece of it, right? A piece of the graph with x only being less than -2. So if I have x is 0, I'm not going to go up on the line because I'm restricted. I can't have 0 in there. I can't have a -1 in there. Can't have a 1, can't have a 2. You with me on that? You'll see it in a second. Then we're going to restrict the x squared, and it says x is between. This is how we write it's in between. We put the x in the middle, put the less than or equal, and it's between -2 and 2. That means that parabola, that thing that went up like this, it's not going to keep going in both directions. You can only graph it from -2 to +2. All right, we're only using that piece of that function. You got it? And same thing with this. They restrict x is between 2 and 5, but it does not include 2. It's not less than or equal to, but it does include 5. All right, so this is kind of weird, but they're just getting you used to this piece thing, this piecewise function. So let's grab this so we have a nice graph to put it on. And let's put it out like this. All right, here we go. I think this will be fine. Tell you what, let's make these all different colors. Let's make that one yellow. Let's make this one, I don't know, pink, okay? And let's make this one blue, okay? Come on, there he goes. Okay, so we'll do them in these colors just so they pop out, you know which one's which. Is that good? Okay, so let's do the yellow one first. It says y equals x plus 3. So what do? We did a y-intercept, right, at 3, but can that even be included in here? It can't, all right? But let's put it on here anyway. I'll get rid of it in a second, but just watch. So what if I graph the whole line like we did earlier, x plus 3? So what's my slope? It's positive. It's a 1 slope, right? Positive 1 slope. So I could go down to the left. I can go here, down to the left, right here, down to the left. Yeah? And I could draw the line. But the thing is, I'm restricted. X can only be less than -2. So can x be 0? Nope. So I can't use that point, can I? Can x be -1? Nope. Can't use that point. Can x be -2? Well, kind of. But it can't be right on it. What does it have to be? It's less than. It's not or equal to. It's an open circle. Very good. So right there is going to be an open circle. So at -2, right? And how do I know where that point is? If I put a -2 in for this, -2 plus 3 is what? 1. So -2, 1. But it's an open circle. What if I put in a -3? Am I allowed to put in a -3? Is it within my restricted area? Yeah, because it's less than -2. So let's put a -3 in for this. What's -3 plus 3? 0. So -3. Yeah, I could put a point right here. And really, what am I doing? I'm just doing that slope of -1 to the left and down, to the left and down. I could keep doing that if I wanted to, but where's my graph going to be? It's going to be from here, and it's going to go through here. Does it stop going to the left? Doesn't, because any number to the left of -2. So this yellow right there is that graph, okay? We're restricted where x can only be less than -2. Normally, if there was no restrictions, this line would keep on going like this forever, wouldn't it? You put the arrow on the end. But this doesn't allow for that. It says, okay, my x values can't be everything. It's not all the real numbers. My x values can only be less than -2. What about this number like just to the left of -2? Is that smaller than -2? Yeah, absolutely. That's why we put the open circle here. And that's why we put all that in there. Does that make any sense? Yeah, so we're just restricting what the x's can be. Let's do the same thing with that x squared thing. So let's change that color. So x's can only be between -2 and 2. So if you wanted to, you could do this little table. So if you're not familiar with the x squared graph, right, you could go x, y. So my x's, could I put a -3 in for my table? No, because -3 is not between -2 and +2. So just like I did before, here's some integer numbers. I can't put anything less than -2, and I can't put anything bigger than +2. All right, and so what's this going to look like? -2 squared is 4, -1 squared is 1, 0 squared is 0 this time. Then 1 squared is 1, 2 squared is 4. All right, so at -2, where do we go? Up 4. 1, 2, 3, 4. I'm going to put a dot right there. And the thing is, it stops right there. Remember before, we put the arrows on the ends because it kept on going? But it doesn't keep on going here, okay? It stops right there. And then -1, 1, could put a point right here. 0, 0, point there. 1, 1, 2, 2, or 2, 4, sorry. Do you see how it's identical on the left side and the right side? We call it symmetric because you could put a line right down the middle. It's kind of like a mirror image, all right? Again, we'll talk about that later on, and it looks like this. But it doesn't keep going. It stops right at that point. So don't keep it going and put arrows on the ends, all right? Some of you guys are sleeping. It's the worst thing you can do. You got to wake up. You got to wake up. Okay, write the stuff down. It's because you're not writing stuff down. Everybody that's awake is writing stuff down. All right, that's all there is to it. It's not much to ask. All right, let's do this one. Remember, this is y equals 1. What was that? It was a horizontal line, wasn't it? And it went through the y-axis at where? +1. So earlier, I drew that line all the way here, arrows both ends. But what is my restriction? I can only go from where? From +2 to where? +5. So I'm not even going to put a point right there. So really, I'm going to go from +2, I'm going to go up to the 1. Do I put a closed circle, though? Because look at it. It says x is what? It's greater than 2. But it goes all the way up to 5. 1, 2, 3. What's that? It's open circle. Yeah, because it includes everything in between, but not 2. This does not include 2. The other one, you do include the 5, yeah. So 1, 2, 3, 4. No, if it does not include it, it's open. If it includes it, right, it's like you're putting the pen right there. Like, yeah, it does include that point. So there's 5 right there. So what's my graph look like? It just looks from there to there. And that is your first piecewise function. It's a little weird. It's kind of like what we've done before in the past, but a little bit different because we really haven't restricted it, okay? You're restricting the domain, right? And that's what it looks like. It's not the only kind of piecewise function we're going to do. We're going to do some more, and let's do this. Did we do, remind me, because I've done graphing in like 3 different classes, and I forget which class I did what in. Have we done absolute value? Have we graphed absolute value in this class? All right. Yeah, I don't think we did. I think in my pre-calc class we did. I don't think we did it in here. So, we did it or not? Okay. All right. So I'll work on the assumption that you did not do it. So let's just graph. I'll do this in a different color. Let's graph y equals the absolute value of x. So if I was going to do a little chart, all right, x and y, all right, let's put some in here. Let's just go -3, -2, -1, 0, 1, 2, 3. It's a very easy chart to figure out. What's the absolute value mean you're doing to a number? Are you just making it the opposite? It's the distance from 0. Very good. That is true. But you just make it what? Positive. That's right. So what's the absolute value of -3? 3. What's this? 2, 1, 0. What's this? Still stays 1, right? It doesn't change it to a negative. Absolute value keeps it positive. 2, 3. So if we were going to graph this, what's that going to look like? -3, 3. 1, 2, 3. 1, 2, 3. Right there. -2, 2. -1, 1. 0, 0. Does it keep on going down? No, because this is the absolute value, right? So all my y values are going to be positive, aren't they? So I'm not going to have anything go down here. And then the other side looks very much like that little parabola thing. It looks like a mirror image, okay? It's symmetric. So 1, 1, 2, 2, 3, 3, and you could keep on going if you wanted to. Again, we have no restrictions on the domain on these. So that's what that looks like. And then there it is. So there you go. That's your first absolute value graph. And it keeps on going because there's no restriction, so you put arrows at the end. So that's what absolute value looks like. It's very simple. It kind of has a slope, doesn't it? Kind of. Like the right side, what is the slope? +1. What's the left side? It's -1, right? Okay, so it slants exactly the same, right? It's got the same slope on both sides, except one's positive, one's negative, and there's your absolute value. But what they're going to do is they're going to ask you to graph an absolute value piecewise, all right? It's not going to keep going. You're going to restrict the domain. So I had to show you that first so you knew how to draw a absolute value graph. So let's push that up. Let's do this. And yeah, we'll do each of these on its own graph. This is example 1, but there's 3 parts to it, okay? So we'll just do 1A on this graph right here. So here's what it says to do. Oh, you know what they do? My bad. They actually give you the graph, and they ask you just to find the domain and range. All right, so they don't even they will ask you to graph eventually, okay? But right now, they're going to give you the graph. So this is kind of what the graph looks like in the book. Let's go green. I haven't done green today. So they have a point -4, 5. 1, 2, 3, 4. Oh, 1, 2, 3, 4. 1, 2, 3, 4, 5. -1, 2. -1, 2. And then 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Right there. All right, here's the graph that they give you. They give this to you in the book. And it doesn't keep on going. All right, this is restricted. See how that points right there and it stops? See that point right there and it stops? So we're restricted. But what does it kind of look like? What does this graph kind of look like? What kind of function does it look like? A what? We just talked about it. We just said the word. Absolute value. Yeah, it looks like absolute value, doesn't it? I mean, this doesn't go up as high as this one, but it's got that V shape, doesn't it? Right? Absolute what? Value. Value V, right? That's a way you can think of it's a V shape. Everybody got that? All right, we're going to be doing a lot more with absolute value later on, not really today. Well, maybe a little bit today. So what I want to do is I want to find the domain and range. Domain and range. So let's talk about the x values. What are our x values restricted to? Like if I go along the x-axis, can I come over here to this x value? No, because if I go up, I'll never hit that line, right? Because the line ends right there. Agreed? So what's the furthest left I can go? -4. 1, 2, 3, 4. Okay? So I can go from, they do it kind of fancy. Didn't I show you this before? X such that. Did I do the such that thing? Okay. So X such that. They do that. You don't really, I don't know. Just trying to get used to it. So X has to be between. Now look, it's closed here. So what's my inequality going to be? Less than or equal, less than or equal. What's my furthest left X point that I could go? -4. What's my furthest right point that I could go? 1, 2, 3. Okay, to 3. Everybody see that? So that's your domain. So you're halfway done. They ask, well, that's a terrible brace. That's better. All right, so that's the domain. Everybody understand that, right? It's the X. Okay, how far over? You can only go to here and you can only go to there. So anything in between, that's my domain. Yes? Okay. What about the range? So the domain is along the x-axis. Where's the range? Along the y-axis. So what's my lowest y value on this graph right here? It would be 2. It would be right here, wouldn't it? Okay. So again, the y value, again, it's closed. So I could put less than or equal to, less than or equal to. The lowest value is what? 2. And what's the highest value? It's 6. It's right here. See how my y values can only go from there to there? All right, that's my lowest y. That's my highest y. It goes from 2 to 6. That's my range. All right, and how do you think they do this? They say y such that, all right? And that's technically how you write it. If all you did was just write x is between -4 and 3, it's fine. I would accept that. No big deal. But they want you to get used to that fancy notation that they put on there. Is this making a little bit of sense as far as domain and range? Yeah. All right. Let's do another. All right. Oh, that's right. I got to draw it. Let's go pink. All right. So this one goes -6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It goes from here to -1, 4. And it's straight. It goes from here to here. All right. Then they give you another one that goes from 2, 2. Right there. And it goes to 4, 2, but it's open at this one. 2, 3, 4, 2, and it's open right there. And it goes from there to there. So they give you this, okay? I mean, they give you this picture on the quiz, on the test, on the homework, whatever. And what you have to do is find the domain and range. So this is a little different. So we'll do the little fancy set notation stuff. So x such that. Now this is a little weird because it doesn't completely go through, it doesn't completely connect. That's why it's piecewise, all right? So how far over on the left does it go? That was a 6. It's a -6, correct? So x is between, so right here, forget this one right now. Just look at this one right here. X can be anywhere between what? -6 and where on the x value? No, on the x, on the x. Where is this on the x -1? Okay, everybody see that? So for this one right here, the domain is between -6 and -1. Yeah? What about this one? So what we're going to do is we're going to put an or between where on the x? 2 and 4, but 4 has to be, it's open, so it's just going to be less than. It's not going to be or equal. This is closed, so that can be or equal. Because the domain could be either this one or this one. So it's kind of strange, right? But you kind of get the idea, right? It's just two separate things, so you just write the domain for both of those. That's all that is. What about the range? So you could do this little set notation thing, y such that. What about this? What's for this one right here? It just is at 4, right? So 1, 2, 3, 4. So it's just at 4. Let's go in order though. What's this lowest one though? This one's at 2. And I'm just going to put, I think you could put a or. I'm not really sure. They put a comma, I think. So I'll put a comma since they do. So the range could only be 2 here, or it could be what? 4 right here. So 2 and 4. Okay? And that's how you do the range. All right. Here's another weird one. I got to draw the thing. This is going to be a... Oops, I don't want that to be blue. Get rid of that. There we go. What's that? Okay, here we go. This one's at negative 4, 6. So let's put a point at negative 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This goes to negative 1, negative 3. Down like that. It's just part of the same example. It doesn't matter. It's example 1 is part C. And this goes to 1, 1. Right there. And this is, it's kind of a skinny one. Well, let's see. Yeah. So this is a parabola. If I can't draw that great. And this would keep on going, but it doesn't. All right. If there was no restrictions, it would keep on going like that. But it starts here, stops here. The bottom of it should bottom out right there. Okay? It doesn't have to be, it's not beautiful, but you get the idea. And then this one starts at, I think, it starts right above it. Does anybody have the book open? Does it look like it's right above there at 1, 2? Because I wrote, in my notes, I wrote 1, 1. It is 1, 2? All right, I must have meant that first one right here was the 1, 1. Okay, and that goes to what, 5, 4? 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, and that goes from that open one to that closed one. All right, so here we go. So you don't really even have to know anything about this being y equals x squared or anything like that. You're just finding the what? The domain and the range. What's that? Which one? The 5, 4 one? Oh, okay. Thank you. So this is open? Okay. All right. So what about the x values? So again, where on the x value? What's the furthest left that you could go here? 1, 2, 3, what? 4. So I'll just do that. Is that all right? Just put a little scribbly thing here. So at negative 4, how far right can I go? Well, look, I could go to here. That does include it, right? But since this is open, this is everything just to the right of 1. So I don't have to stop here. The x value keeps on going all the way until we get to here. Would you agree? All right, so because this is right above this, so the x value, if I go to here, yeah, that's possible. If I go just to the left of there, of that 1, yeah, that would hit the graph, so that would be in play as well. So how far do I go? That's to 5. So what's my domain then? I won't write all the fancy stuff just for time. It's what? So x is between. Now it does include negative 4, but it does not what? doesn't include 5. This should just be less than 5. And that's the domain. Make sense? Okay, what about the range? The range is how far down on the y-axis can you go? Well, to there, which is where? -3. And how far up can you go? Well, yeah, you can go all the way up to here, can't you? What about, is there any gaps in between though? It looks like there's a gap here, but if I keep going up, see where there's a gap between here? That's kind of already included in here, isn't it? Right? So really, every single y value is included from where? From -3 all the way up to what? +6. You see that? Because it looks like there's a gap, and there sure is a gap here, but it's taken up by this gap from here to here. Right? That little part of it kind of fills that gap, if you want to call it that. All right? So it goes from -3 to 6. Are they less than or equal, or just less than? They're or equal. Both of them are equal to each other. All right? Because right here is closed, and right here is closed. And that's your domain and range for something crazy like that. And the books love the domain and range stuff. Okay, pre-calc started with it like right off the bat. Right off the bat, they started with functions. They started talking about domain and range and all that kind of thing. Now, what they're going to do, I'll tell you what, I'm just going to save us a little bit of time. Yeah, there's no way I'm finishing this whole lesson. I kind of thought last night that I think if I start right away, I can do this whole lesson, but there's just no way. So I'll continue tomorrow. We'll take the quiz tomorrow, and then when's this class over? 14. Yeah, we're almost done. Yeah, we'll stop there. Okay, and I will eventually give you homework on this. I'll show you what it is. Oh, I didn't write it down. It's on the lesson plan. What does it say on the lesson plan? 7 to 28. So you obviously won't be able to do 7 to 28 tonight, okay? But look at it, see how much you can do, and then get that done so you don't have to do it all at once. That would be a good thing, okay? So I don't know how far it is. I don't have the book open right now, so I don't know how far we got. Obviously, you're not going to be able to do them all, okay? But do as many as you can so that you're ready for when I assign the rest of them. It's assigned whenever I finish the lesson. Okay, so it won't be assigned until I actually finish teaching the lesson. So I don't know if that'll be tomorrow because half the class is going to be taken by doing the quiz. So yeah, I think I was a little optimistic. I was ambitious. That's a good word. I think I was a little ambitious when thinking I could do this in one class period. But obviously that changes things the rest of the week. But that's right. We'll roll with the punches. No big deal. Okay? Give it one more minute. Give it one more minute. Okay, until it's actually 2:14. And then you can go. Because I don't know if the bells are ringing. They didn't ring last period. I don't know if they're ringing now or not.